Okay, this is section 3.1, and we're going to talk about special systems. Now, um, you've already graphed systems, and you know that in order to find the solution to a system, it's where the two graphs intersect. Okay? And so you've seen this part right here. This is an example of what you've already seen before. Okay, two lines, they intersect at one point, and that one point right there is the solution. All right, so those are regular old, what we call one solution systems. Okay, there's one answer. Now, not every problem is like that. Okay, it's possible that you could have what we call infinitely many solutions, or in this case, I have one graph on top of the other. Okay, so some things you might want to write down here that tell me. Okay, if you remember, we're getting equations in the slope-intercept form every time. So in this case, you would have the same slope and the same y-intercept. For example, maybe you have y equals 2x plus 3 and y equals 2x plus 3 when you get done. You'll notice those equations are essentially the same thing. That means one's going to be on top of the other. And how many times does one line intersect with the other? Well, it intersects at every single spot. So we don't know how many points there are here. That's why we call them infinite solutions. Okay? Same slope, same y-intercept. Now, it is also possible to have no solution. Now, no solution is going to be an example where you have parallel lines, or two lines that don't or never will intersect. Okay, so you have a no solution possibility. Now, how do you know if it's no solution? Well, in this case, the slopes, they have the same slope, but they have a different y-intercept. Okay, so they have a different y-intercept. An example of what equations would look like, maybe it's y equals, we'll go 1/3 x plus 2, and y equals 1/3 x minus 3. Okay, if you study these equations, you notice the slopes are exactly the same, and the y-intercepts are different. Okay, so again, I'm just going to kind of quick sketch this. You would go on this guy right here, you would go up 2, put a dot, and then you would go up 1 and right 3. So your graph would look something, just quick sketch like that. Okay, and then on this one, if I quick sketch this, you'd go down 3 and put a dot, and then you'd go up 1 and right 3, and you would end up with two lines that are parallel. Well, if you have two lines that are parallel, they'll never intersect each other. So if they don't intersect, you can't find an answer. So therefore, that's why if they don't intersect at all and they're parallel, there's no solution. Okay, now, in today's practice problems, I'm going to throw, you're still going to graph them, just like you were before, and then you're going to be able to tell me, okay, if it's one solution, you find the ordered pair that's the solution. Again, if there's one solution, your ordered, it's just going to look like this, 5, comma 4, wherever they intersect. Okay? Or it could be infinite solutions. It could be one on top of the other, where there's only one line in the picture. Okay? That's infinitely many solutions. And then no solution would be two lines that are parallel. Okay? We're going to throw all three of those into together today in your examples. But just remember, again, in your examples, you want to get y by itself, just like before. None of that's changed. Okay? In your equation, get y by itself, get it in slope-intercept form, and then graph it in slope-intercept form, and then you'll be able to tell me if it's one solution, if it's infinite solutions, or if it's no solution. Okay, if you get an ordered pair, it's 1. You get one line, then it's 2. If you get two parallel lines, it's no solution at all. Okay, now you should be able to complete the examples down here below.